Alright, hello and welcome to the stream. My name is Nick Larson, and we're just going to get right to it, I guess. Today, we're going to do the same thing that we do every day, a little bit of AI, a little bit of chatting, and just hanging out. 2 seconds here to finish what I was working on, and then I'll get started. First off, we want to come into here. Alright, first off, we're going to come into here. Take a look at this thing that we were doing last time, which is we set it up so that we can test the A star and get a little bit of output and actually see it running. We were trying to do a much larger puzzle. This is a 4x4 puzzle instead of a 3x3 puzzle or a 3x4 puzzle, both of which we were able to solve relatively quickly. Let's go ahead and just take a look at that one more time so that I can feel like I'm not just making that up. Solver test. And run the solver test. Just want to run... Alright, so this one right here and this one right here, and then this one not going to work. So if we run these, we'll see that they run pretty quickly. It won't be instant. Oh, maybe it will. It'll be pretty close to instant there. So it solves both of these and it gets the optimal value. It only has to expand about 8,000 nodes for that one. Only has to expand about 30,000 nodes for that one. But as soon as we turn it to a 4x4, the state space gets quite large and it stops being so quick, really. And it will run and run and run, and I'm not going to do it again. But basically what you can see is this is the output of it. And this happens every 10 seconds. We get a new little ping that tells us the total number of states that have been evaluated up to that point, the total number of states that were evaluated in the last minute, and then the total cost, or excuse me, the minimum cost of our search frontier. Now we know that the solution... Oh, that's interesting. If this takes 45... and we have a cost of 47, we are already not finding the optimal. So that's a pretty strong indication that there's a bug, or I put this number in there incorrectly. Where did I find this? Let's go take a look. I found this. I found this in scholar.google.com, and then I went for pattern databases, and then I went and took a look at this. And if we go and we search for, oh, you know what, they're not in here, they're in the Corf one. We want to go to Corf 87, Corf 1985, that's what we want. Uh-oh. How about the second try? No, that's not good at all. That's really not that good. Get access? Come on, Science Direct. Wow, I just had this. Where is my library? And let's go for Corf. Disjoint pattern databases. Additive pattern databases. Efficiently solving the 15 puzzle. Okay, I'm searching with pattern databases. I guess. I really thought this was going to be a little bit easier because I was looking at it last time. Basically what I'm looking for is a giant list of oh, here they are. These are 24 puzzles, which is not what we want. We want the... Great. All my Corf 1985s are gone. No, that's not what he wanted. Pattern databases. Come on one time. They're not going to be in here, are they? Basically, I'm looking... Oh, here we go. No. This is where I say Corf 1985. That's what I'm looking for, is Corf 1985. Corf 1985. Let's go take a look at this, and hopefully we can actually find it. Let's go to Google Scholar. That's not what I wanted. Iterative deepening. Corf 1985. Oh man, come on. This is really gonna give me... Go back to the problem. What a frustrating start. Depth first, iterative deepening. 22 revisions. Let's try it on one of these other ones. There we go. Alright, I chose the one that was the smallest. Ooh, actual 45. Yeah, that means we have a bug. The min? Let's just be sure that I'm checking what I think I'm checking. Total evals, current evals. Solver.maxCost evaluated. Okay, let's see how that gets set. Solver.maxCost evaluated. Solve the in puzzle. Well, I guess the first things first, let's just check to make sure that I actually put the value in here that I think I put in here. Wouldn't be the first time I've made that mistake this week. There it is. Okay, we're looking for... I can't highlight these. That's awesome. We're looking for this one. 14, 1, 9, 6, 4, 8, 12, 5, 7, 2, 3, 0, 10, 11, 13, 15. All right, well, I got that right, and it says the actual should be 45, but I am searching 48. So somewhere there is a bug. That's great. Let's take a look. Estimate. Manhattan distance. Estimate for this is 35. Let's see if I'm calculating that correctly. So test Manhattan distance. This is in puzzle test. Test Manhattan distance. Inline data. 4, 4. Oops. And this says 35. Let's just run that test. Ooh, I failed one. Crazy. Expected 35, actual 37. Oh, hey, what's up? There you are. Say hi, I'll only be able to stay around 15 minutes. Hey, I appreciate you stopping by, man. I hope you had a good weekend. And first half of the week, really. That's cool. Yeah, things like got super hot here all of a sudden. Oh, but hey, since you're around, a couple of quick updates. Look, my video should be a lot better. I got some nice clean new fanciness going on. I got a for real green screen, which is funny because now my shirt is actually kind of matching in, and so it's looking a little funny. But anyway, yeah, I also got a second camera set up. Check this out. See? Here I go. Yeah, the green screen right here. And then you can see my shirt is like similar. So it's kind of having trouble with it today. Thanks, man. Appreciate you stopping by. I'm just going to keep grinding away on this. I just ran into a bug. Show and tell cam. That's right, yeah. What else did I get? I didn't really get anything. This is just it. But yeah, I got the video sort of figured out. I was using the built-in default resolution, which is like not really that great, and I jacked it up a good bit. It won't let me go to the max resolution because it'll only do a few frames a second, and it's like so I just gave up on it. But yeah, I think I'm doing like 1080p on the camera now, and it looks a lot better. It's a lot sharper, so I'm happy with it. But anyway, yeah, I got to get back. I got to figure out what is going wrong with this Manhattan puzzle distance right here for my 4x4, because that is what's causing this to not finish, and I want to figure out what that is. Yeah. Do you stream in 1080? Right now I'm streaming in my monitor resolution so that I don't have to change the resolution of my monitor each time I start my stream. I'm thinking it's a little too big though. Somebody was complaining the other day about not being able to view it on an iPad, which is surprising to me because iPads tend to have pretty good resolution, I feel like. Maybe it was just too much data going over the wire or something, I don't know. Or through wireless, I suppose. Anyway. Alright, I gotta figure this one out. Test Manhattan puzzle distance. We just comment these out, and we can debug this test by putting this in here and clicking on debug. Oh, you got a 4K screen, okay. Right, but the only issue is that like my resolution is 1440, and so there's not like a direct mapping. It's not like, you know, shrinking it in half, and I got a lot of blurriness on like the details of things when I did that. Maybe I'll try it though. I gotta get it fixed, whatever, because, you know, I like watching things on an iPad. It's very easy to walk around the house with an iPad as opposed to like a laptop or whatever. So I definitely gotta check that out. All right, let's take a look here. First off, let's just see if this is the state I expect, which should be 14196, 14196, 48125, 48125, 7230, 7230, 10, 11, 13, 15, 10, 11, 13, 15. Okay, so that part is right. The initialization did well. And now what's going to end up happening? You know, it's also possible that there was a misprint. It's always a thing. I wonder if there's some errata. Maybe. Let's go ahead and step into here and just see if I agree with this or not. I guess one way to do this for starters would be to put what we expect. Let's go with I want to say state.toString, and then copy this, copy value, and then give me a new tab, and then delete these out, delete this out. Delete this out. Delete that out. All right, so this is what we expect Now we need to calculate it from here. How do I drag this to the side? Like that. That's how. Great. Okay. Now we want to look through this and do it one by one. So the 14 needs to move. Where is the final state of the 14? It should be right here. So it needs to move 2 over and 3 down. So 14, let's just do it like this. 1, 2, 3, 4, 5. Let's just do it one by one instead of sitting here and tile value 14. That's correct. Top left corner. Tile value not equals 0. Then the expected cell location should be 14 or 15. Oh. Well, there you go. Maybe that's our problem right there. Expected cell location. Should be... Oh, that's right. The 0 needs to be down here in the bottom. Okay, yeah. So 13 is correct. Expected row is 3. That's correct. Expected call is 1. That's correct. Okay. So the actual row and call, the cost is now 4. Oh, that's right. Okay, so it goes over 1, down 3. Great. Expected location 0. Can I get rid of this? Remove all. Shrink it. There we go. Remove all. Expected row, expected call. 0, 0 for the 1, so it needs to move 1. Great, so 5. That was right. Tile value 9. You know what? Corf 95. Before I get too deep into this, Corf 85 errata. Aha. Errata. Some necessary changes in citations, suggested changes based on recent. Okay, that's another thing that we could look up, which is, let's go take a look. Let's go take a look and see if there is a later version. You know what? I just have the answer to this. I know the answer to this because I've done this before. So we're just going to go find that. Let's go to code. Goodness me. Where is this going to be? Heuristic search. Source. In puzzle. Corf puzzles. Open with Sublime Text. All right. What number of the Corf puzzle was this? Go back. Go to the one that worked. This was Corf 12? Corf 12. Okay. Actual is 45. Ah, great. We didn't put the Manhattan distance in there. Okay, well then I guess we just have to keep going through it and seeing if that is correct or not. 15 puzzle instances using iterative star with Manhattan distance heuristic function. Estimate. It's not strictly a tree. Okay. Let's go ahead and keep stepping through this then. I really feel like this is doing the calculation correctly and that that's a misprint. What are we on now? Tile value of 9. And 9 should be in row 2, column 1. So we need to go 1, 2, 3, 4. This should add 4, bringing this to 9. Okay. Tile value. Oh, you know what? Maybe I need music. What kind of music would you like? I'm not sure that I have anything on here that I could play without getting in trouble for it. At all? Do I have anything? I have Hearthstone. Can I play Hearthstone? I don't know. I'm just going to keep grinding away on this. It's tile value 6. 6 needs to be right here, so it needs to be 2, 1. It needs to add 3. This needs to bring the cost to 12. Okay. The second row, tile value is 4. 4 is needs to go up 1 and over 3, so this should add 4, bringing this to 16. Okay. This is tile value 8. 8 needs to go right 2, so this should add 2. Okay, 18 from 16. We're still doing well. Anything just helps with the atmosphere. Let's see here. Can I go to Windows Media Player? And then let's go with, how about a little OAR? OAR would be cool. Could do a perfect circle. Could do a little tool. I'm gonna go with this one. All right. That's not what I wanted at all. Can y'all hear what I am hearing? Main computer audio? Yes, you can hear what I'm hearing. Let's go with this one. Main computer audio. Why is this not happening now? Click to switch off. Where is it? Ooh. Set it up. Properties? Feel like that's the right one. Speakers. Oh, yeah. All right. Check this out later. Okay. Okay, so we're at 18. I lost track. I'm going to just pretend that that's correct. What was the last thing we did? 8. We were at 16 before this. We just added 2. Okay, I feel good that this is right. Tile value is 12. And the 12 needs to go right and down. So it should add 2 again. This should bring us up to 20. Okay. This is a tile value of 5. 5 needs to go left 3. So this should add 3 and bring us to 23. Okay, still doing well. Next row, this is 7. 7 needs to go up 1 over 2. It should add 3. This should get us to 26. Okay, that's good. This is tile value 2 needs to go up 2. Should bring us to 28. Okay, feel good about that. This is tile value 3 needs to go up 2. Should bring us to 30. Find it really hard to believe that these last 4 are only going to need to move 5 spaces. Well, maybe they are all on the last row. So maybe tile value. Did you notice that? Oh yeah, we skipped over it because it was 0. We don't add anything. Next one. Tile value of 10. 10 needs to go up 1 over 2. No, up 1 over 1. So that's going to add 2. 32. Still correct. Tile value not equals 0. $11 needs to go up 1 over 1. So that's going to add 2. Okay, now we're definitely going to go over. Yep, that's 32. 13 needs to go left 2. 15 needs to go left 1. That's 37. All right, this is a misprint. Like, doing this by hand, I feel very confident that 37 is the correct value. Now, the other misprint might be that 45 is the correct solution, or the correct solution. Maybe it has to do with the way that we're actually setting. Okay, so, all right, so this is 37, not 35. So solver test, nope. In puzzle test, this should be 37, so that's a misprint for sure. Those things happen, by the way, when you're reading papers that are published, even in like big, huge journals. Just be aware that there are misprints all the time. Oh, is this the A-star solver? Hey, welcome to my stream. And yes, to answer your question, I am working on an A-star solver for the moment. What we're doing is basically just trying to figure out why it's having such a hard time solving like the easiest 4x4 problem ever, which is this one, which I just deleted, which is awesome. It's this one basically. I don't want to debug that. How do I stop this? I can't stop that. Yes, I can. Okay, great. Stop it. Okay. All right, so this is an A-star solver, and we're trying to solve this starting state using the Manhattan distance. Have you done the inversion checks? I pulled these directly. No, I pulled these directly out of Corf 1985, which are randomly generated states that have been passed, and he solved using this. And this is the easiest one that there is right here, number 12. And he claims that the Manhattan distance estimate should be 35, but I just did it by hand. Right, half of the states are unsolvable because of the inversions. So again, the point though is just that I was trying to do this, and he claims here that the actual is 45, and based on some previous work that I have done, I believe 45 is correct. And this should be one of the easiest ones to solve using Manhattan distance heuristic. We are not doing iterative deepening yet. Haven't gotten there. Instead, what we're doing right now is storing a giant, open set, closed set sort of a thing. And then I just want to get to the point where... So I ran this test the other day, and what ended up happening, if we go take a look at the output right here, is it was evaluating states of value 47, but we claim that the correct output is. See you later, man. Thanks for coming. I will have a fun one, and I'll see you soon. Probably later on today. Um, so the output was telling me it was finding a distance of 47 almost immediately, which is not correct. Oh, so this is another thing that we need to do. Test whether or not the solution for a 4x4 is coming out correctly. Test default initialization of a 4x4. Run test. See if our goal check is failing. Nope, goal check is not failing, which means that the 4x4 is correctly finding it. The default initialization is just the goal state for each of these, is the way that we built it. Let's see here. I guess another thing is that maybe I ran something different last time, and I think I ran what I was intending to run. So let's just delete these out. And let's just do a test one more time. I put this thing in to do that tells me how to run it. Nope, I didn't. That's not great. Okay, terminal. I want to run cd, I want to .NET test, and I want to say filter equals fast.search.test solver test, and then I want to run just this one. I'm running this in a command line because I can kill it from the command line, but I can't kill it if I just run the test. Which is kind of like, I don't know, I wouldn't call it a bug. I would just say it's a poorly thought out part of what's in the integration with XUnit in here. Or maybe I'm just using it wrong. That's always a possibility. Solver test, test A star, search Manhattan distance. All right, so I want to run this one test on this state, and then I want to look at the output, and I want to make sure that the value that it's coming up with, that's the other thing I wanted to do. Solver.maxCost evaluated. Oh, great. Where are my solvers? A star search solver. When am I actually filling out the max cost evaluated? Here it is. So I pop a state, and then I mark down the max cost evaluated. Oh, you know what this is? Is this the cost to get there, or is this the total cost? Because it would be really awkward. Let's just see. When I push a state on here, I am pushing a state cost. A state cost is a state and a cost. Now, when I fill out that cost, am I filling out that cost correctly? State cost. How do I go back? Is there a magic button for back? Does anybody know of one? Like in Visual Studio, there's like a left arrow button. You can press that to just go back quickly. Okay, I guess we're just going to go back to it like this. There we go. So what I am saying is cost plus step cost. Okay, so no, this is the correct one. I'm only adding the heuristic for the top level cost. And somehow I am saying that I have explored something that has a cost. Am I correctly calculating previous cost plus the step cost? Okay. So let's just take a look at this. And then I guess we can also do it for the other ones, and then we can also see if it works for the other ones. And then we'll know our answer. .NET test filter. Let's see. XUnit run specific test during .NET test. Oh, dash filter. Sure. Dash filter. Okay. There we go, and now we've got some output, and this is just going to scroll through and show us what it's doing. And what we're looking for is the cost. If the cost goes over 45, which it has, then there is something wrong. Okay. So this is the biggest problem that we've done, and it's quite possible that just because it's the biggest is the reason there's an issue here. I want to go ahead and take a look at the previous ones and see if we can figure it out from the previous ones. So we're going to go to solver test, and we're going to change this Manhattan distance one to one of these easier ones right here, and see if this one tells us. All right, yeah, max cost of 31. So somehow we are evaluating a cost that is not the minimum cost. Okay. That's really kind of lame. So what I want to do is set up a little breakpoint that says to stop when we have gotten to the point where we feel like we should have a better score, where we should have found the goal already. Okay, let's do that. We have, when I pop it off, if cost equals 46, then we have gone too far. So what I want to do is basically just say, console. I don't know C#, but is that a priority queue? Yeah, C# doesn't actually have priority queues, so I sort of hacked together some stuff, and it's very likely that my hacking together of an open state is what's causing this problem. So follow along with me on the open state, please, and let me know if anything stands out to you, just like, in an algorithmic sense. So for an open set, it needs to be a priority queue, but it needs to be a priority queue based on the score that includes the heuristic, and then it needs to determine set membership based on the actual state. And there is nothing in .NET that supports those two actions at the same time. Everything wants to sort and determine uniqueness by the same value. So instead, I tried to implement my own, and the way that I did that was I kept two dictionaries. One is a sorted dictionary that has the cost that is not just that includes the heuristic cost, and then it's just a hash set of the actual states. So every single one of the states that has a cost of this, you know what? Is this my problem right here? I'm popping out the cost. Yeah, maybe? Okay, again, just keep following along. So I have two dictionaries. One is you give me the state, I can immediately look up the cost. That's how I can determine set membership immediately in constant time lookup, is by having a dictionary that is keyed on the state. Then I have a second one that is keyed on the cost and sorts by the cost, and then maintains all of the states that have that cost. Oh yeah, okay. So the state here is not what you think it is. This is my state cost. Let's go take a look at the actual solver. in the solver, my open set I am creating as a state cost, and a state cost contains a state and its path to that, its cost to get to that, and then the cost for the actual open set is the one that includes the heuristic. So this one does not include the heuristic cost. This one does include the heuristic cost. So the state cost, basically this get hash code ignores the cost altogether and only returns the state. So you have a Manhattan cache and popping based on min cost. Yeah, I do. I think so. I hope so. That's the intention. Yes. Really, I think like the first thing that I want to do is I want to debug this, and when it gets to 46, I basically just want to tell the debugger stop, and then let's inspect the open set and see if I just have some bad logic as far as grabbing things off the open set, and see if that works. Not 100% sure if it's going to or not. It's also possible. So the open set also has another concern, which is when I add something with a lower cost, I need to update the lower cost. And it's possible that I'm just not doing that correctly, and I'm just not running into that problem on the or that issue on the smaller problems, the smaller in puzzles. Let's just start here and say when it's 46, let's just int I equals 4. Hit this with the debugger, and then let's debug this in puzzle test. Not the Manhattan distance, no. Open set test base, solver test, there we go. And now this one, do the big one, do debug test, and now I'm just gonna wait for it to hit this breakpoint. Anyway, thanks for hanging out. I really appreciate it. It's also nice to have somebody to like look at this with me. Another set of eyes always makes it easier to look through things. Okay, so what we have done is found a cost of 46, which is not good. What we want to look at is the open set. And now the open set claims to have a cost of 49. Min cost. Open set. You know what? I think I'm looking at this incorrectly. So there's a lot of items in there. Cost states, everything is either 49 or 51. So as soon as we found a cost of 46, we have already gone too far. That's not good. All right. So the min cost might be calculated. Min cost is cost states .first.key. So we just popped off a 46. We don't have anything less than that, and we didn't find it on 45 or below. Okay. So we are somehow not adding states that can get us to a goal, or it's going to be impossible to walk through like 5,000 states or even 10,000 states by hand. So really what I want to do is just do some lower values and see how close we get. Let's do 43. When we get to something with 43, we can now take a look and see how far away we are and see if that helps it. So the min cost, do I even care about min cost right here? Does anything even use this? Probably not. Min cost. Well, 3 things use it. Assert.equal, and they're all test. Do you have that specific 4x4 puzzle? I sure do. Right here. And I'll go ahead and format it for you. So this is going to be like this, 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 like this. That's the puzzle right there. Go ahead and just hold it over here. That's the puzzle that we're starting with. Are you going to check the inversions? That'd be great. I checked this in 2 different ways. I checked this against the paper, and then I also checked this against a previous implementation that I had done to make sure that it was in there. It's very possible I've looked at it incorrectly though. Let's go ahead and stop this when we get to 43, which we have already set up. And then I just want to take a look at it and see how close we are and see if we're just making a huge mistake. Okay, so the closed set. How many items are in the closed set? Give me a count, please. Goodness me. Probably shouldn't have clicked that button. Okay, what about the open set? You seem to be working pretty hard. You know what? Let's go ahead and stop this. And try again. Debug. Okay. 43, open set. You gonna give me anything about the open set? Or are you just gonna crap out? Seems like you're gonna crap out. Alright, we got that one. We got that one. We got that one. Can I have a state, please? There we go, state. Why is this having such trouble? Just show me what's in the state. Copy. Copy value. This is what it's at right now. Oh, and look at that. That's the goal. Why is it not finding... Oh, no, it's not. Oh, look at that. The inversions are backwards. Yeah, you're right. Okay, so you're right. I have something wrong here. Because the inversions... This is a single inversion and everything else is in the correct state, so it's definitely never going to get to a solution. So... I have done something wrong. I am going to guess that this is this a bug in my swapping? Or is this I typed the state in wrong and I've been looking at it wrong over and over and over and over again? It's not possible to fix this, right? Because this is a single inversion. If you're still here. Okay. So this is definitely a bug. Definitely a bug. Is this a bug in my swapping code? Is this I just typed in the wrong starting state? Which we can go check one more time. Which is just this. Okay. And then if we this in here. And then this is my starting state. Well, actually, give me this is right here. 14.1. Okay. All right, I believe this is a bug in my swapping logic. Although we could just sort out the number of inversions by hand. Uh, 14 needs to move. It's only left. How do you do it? It's only to the left, the number of swaps you have to do to the left. So that's 1. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. No. Okay, this is a totally valid state. All right, yeah, I believe this is a totally valid state, and now what we need is to figure out where my swapping is going wrong. Okay. It's amazing that you run into a swap on a 4x4 board that completely breaks it, but on the rest of them it's fine. A star search solver. Nope. In puzzle state, make move. Hamming distance, move copy. Move. And of course, this is going to be the most complicated part of the whole thing. Let's put this back over here. Let's close that. Let's close that. Let's close that. Let's close that. In puzzle. Okay. So the new blank is going to be at the new blank location dot row times the number of bits times the number of calls. So this is 4 times 4 is 16. Bits per row. Yep. And then the new blank call is going to be value bits 4 times the column. All right. This dot blank row. Is there any place where I am making a mistake on the topmost bit? Because I could definitely see that causing a problem. Val. Okay. So I am saying mark the lowest 4 bits as activated, shift them to the correct place, negate the entire thing, and it with the board. That takes whatever's in that location and sets them to 0 and leaves everything else what it originally was. This dot board long board. Is anything in here that would convert this to? No. And then what I'm saying is in the old location, I need to set the value, which is just activating those bits and then saying the old board or this. I'm not entirely sure. Is this problem solvable? That's a great question. Check if in puzzle is solvable. How to check. Given a 4x4 board, so every tile from 1 to 15 except the blank space, the objective is to place the numbers. Great. If in is odd, here X marks. In general, for a given width of in, we can check to find if an in times in minus 1 puzzle is solvable or not using, if it's odd. Please don't ask me to sign up for anything. Come on, man. If in is odd, then the puzzle instance is solvable if the number of inversions is even or... Okay. What is an inversion? If in is even, puzzle instance is solvable if the blank is on an even row counting from the bottom and the number of inversions is odd, or the blank is on an odd row counting from the bottom, last, third last, fifth last, etc. And the number of inversions is even. For all other cases, okay, so in this case, we have it's on an even row, so the number of inversions needs to be odd. If we assume that the tiles are written out in a single row, a 1D array, instead of being spread in rows, 2D array, a pair of tiles, A, B, from A, B form an inversion if A appears before B, but A is greater than B. For the example above, consider the tiles written out in a row like this. The above grid forms only one inversion, 2 and 1. And because it's on an even row, the number of inversions needs to be odd. So that is solvable? Okay. In equals 4. Position is in the second row. Oh, so it's odd, so it's solvable. Okay, let's just count them. The 0 is down here. So the 0 is on the bottom. The 0 is on the bottom. Which is odd, so we need an even number of inversions. Okay, let's just work out the total number of inversions here. Okay. Let's try this one more time. We have, it's on an even row. So we need an odd number of inversions. Okay. One, two, three, four, five, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. I have 27. So somehow we are getting from a number of inversions that is odd to a number of inversions that is even. All right, so what we're going to do is I think we're going to write a tool, a little function that can tell us whether or not it is solvable, and then as soon as we find out that it is not solvable, we're going to see the state that came before it. Okay, great. That's perfect. Okay. That's great. I don't want this debugging line in here anymore. I want the solver. I want to write this thing called private bool is solvable. Yeah, let's put this on in puzzle actually. Okay. Public bool is solvable. All right, this is going to do some work. This is going to say inversions, int inversions equals 0. For int I equals 0, I less than state. Yeah. That's a real pain. How did we do this? The first one is the top left-hand corner. And we want to test it against all of... Okay. Let's just do a while true. U-long value equals this dot board equals this dot board. Okay. While true. And now what we want to say is value, let's call it board, call it B. And we're going to say u long value equals B and 0xFUL. So this is going to give me the value of the lowest tile. And then I want to say for u long O equals B right shift value bits. And then we want O greater than 0. And then we want O right shift equals O right shift value bits. Okay. Var u long other equals O and 0xFUL. Okay, so this gives me that value. And then what we want to say is if other is greater than 0 and value is greater than other, in that case, it's probably faster to do it this way. In that case, inversions plus plus. And then we want to say, no, I think that's it actually. And then we want to say B equals B right shift value bits. So what this does is it says, give me a copy of the board so that we can manipulate the copy. It says, give me the lowest tile value. And then it says, and then we can just say, if value equals 0 UL, continue. Nope, can't do that. I want to say if value not equals 0 UL, then we want to do this for loop. And that is hard to read. So let's put it like that. Okay. So if it's not a 0, then we want to take a look at it. Then what we're saying is, all right, shift it over. Give me the lowest 4. Then see if my value is greater than that, and that my value is not 0. Then we add an inversion. Now what we need to do is know which row we already know which row the 0 is on. Okay. So now what we need to say is, if rows this dot in rows mod 2 It's not mod. Remainder 2 equals 0. If it's odd, that's the easy one, right? If it's odd, if n is odd, then the instance is solvable if the number of inversions is even in the input state. Okay? Number of inversions is even. Return inversions remainder 2 equals 0. Otherwise, we want to say if this dot blank row mod 2, this is starting from the top, it would call the top 0, which is even, because from the bottom starts with 1, and that's what's considered odd. Mod 2 equals 0. How about like this? How about we just say, okay, 0, okay, bool 0 on even row. And then we can say return inversions zero on even row. Okay. Bool inversions even. Inversions even. Okay. Let's get back to the logic one more time, see if we can figure this out. Inversions even. Okay, if the blank is on an even row counting from the bottom, and the number of inversions is odd. If the number okay, so even to odd, odd to even. Even, return 0 on even row, even to odd, not inversions even, or inversions even. Okay, even to odd, odd to even. Okay. Let's do a little test of this is solvable thing. Let's just do a little test. Solver test. Not solver test, I want in puzzle test. Let's trash these, delete, close that. In puzzle test. Okay. Let's try all of these. And we're not going to need these anymore. Sort of. True. 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 Didn't actually, I don't know the answer to these. This one should be true. Okay, test in puzzle is solvable. Is solvable. Bool. State. Initial state r equal expected and state dot is solvable. Run this. I seem to have screwed this up. Oh, you know what? I didn't break. Crap. And I ran this. This is what I'm talking about. Go ahead and bring that back up. I think you can actually kill it. I think we figured this out the other day. It's just kind of a pain. You have to like go into here and then you got to find the one that's like doing all the work. There we go. Okay. Now what I want to do is say is solvable. I made the mistake here of not ever exiting. So now what I want to say is while b is greater than 0. UL. And let's try that one more time. Solver in puzzle test. Debug the test. Nah, just run it. Oh, one of them failed. Which one failed? Equal. How do I know which one failed? That's really kind of frustrating, actually. Line 64. That's really frustrating that it doesn't tell you which of these failed. I'm going to guess it was one of these. KC. Or maybe... Let's just run this. Debug test. Run test. Failed. Interesting. Why do I feel like I am doing this wrong? Didn't we do this by hand? Let's debug it. Let's debug it. Come on now. I'm really gonna grind myself here. F11. Inversions. Word. Blank row is 2. That is an even number from the top. Right? Right. Yeah, see, there's our representation. And we see that it is an even number of ways. So we want the number of inversions to be odd. Okay, great. So board, some really giant number. The first value is 14. Then we're going to compare 14 to 1. Other 1 inversions plus plus. Value bits. The next number is 9. You know what? We can do this a much easier way. No. No, just keep the hard. Just keep it going. Solver test, no. In puzzle test, yes. Debug test. All right. Inversions. All right, we see 14 is greater than 1, so we're going to count it. We see 14 is greater than 9. We count it. We see 14 is greater than 6. We count it. Other is 4. Other is 4. We count it. Other is 8. I'm really just looking at these right now to make sure that we're actually getting the values that we expect. $12, 5, 7, 2, 3, 0. 5. 7. 2. 3. 0. 10, 11, 13, 15. 10. 11. 13. 15. Okay, so it does the outer one correctly. It shifts the board state over. Now it should be 1. The value is 1. Okay, great. Value bits. Other is 9. Skips it. It should skip almost all of these. In fact, it should skip all of these. So if we go all the way to here, we should not have changed the inversions, which we did not. $14 returned 13 because that's how far away it was. That's right. Okay. Then we have 9. And this should increase it by 7, so we should be up to 20 at the end of this one. Okay. And then we have 6, which should increase it by 5, so we should be at 25. Ooh. Oh, yeah, no, that makes sense. It should have increased it by 5 minus the 1, which was smaller than it, so 4. Okay. Next one is... Next one. Next one. Next one is... Four. And this should increase it by 2. Okay. And then this is 8. And 8 should increase it by 7. 6, 5, 4. This should bring it to 30. Okay. Wow, that's a lot of inversions. 30. And then we have 12. 12 should increase it by 1, 2, 3, 4, 5, 6. So this should get us to 36. Okay. And then 5 should increase it by 2. So 38. Okay. And then 7 should increase it by 2. 40. Great. And then the value is 2, and that should not increase it at all. And then the value is 3, and that should not increase it at all. And then the value is 0. Did not increase it at all. And then the value is 10. Did not increase it at all. And then the value is, yeah, none of these are going to increase it for the rest of this. 13, 15, and that's it. Okay, so the number of inversions in this case is even. Blank row is 2. So I got even. Wow, this is not solvable. That's really mind-boggling. Yeah. Let's just see if there's a plug it in sort of a sort of an example here. Let's just try it out. What happens if I run this? Compilation, no such file or directory. That's awesome. Okay. That's great. Error running query. That's awesome. Let's go new one here. Then let's go to essentially just copy this code. Okay, don't need any of this crap. Or is solvable equals new is solvable dump is solvable get inversion count. Okay. Int in equals puzzle.length. Okay. Get inversion count puzzle. I fail to see why you don't like that. Okay. For equals in this case I want array.length, and in this case I want int array I equals array of I. Oh, I see what it's doing. It's flattening it. And then it's doing it. Okay, yeah, let's do it like that. That makes sense, actually. So let's take this and let's leave it like that. And then we want to just say puzzle dot select mini to array, flatten it, okay, so if this one is in and 1 greater than 0, I don't understand the problem there. Int and bool. Okay. Not all code paths return a value. Return in minus I for, yeah, no, we just want to do it like this. For int I equals in minus 1. How about we just say int find x row for int I equals in puzzle dot length minus 1 I greater than 0 I plus plus I greater than or equal to 0, and then we want to say if puzzle dot index of dot contains 0. Nope, that's my problem. Puzzle I dot contains 0 return in minus I. Puzzle and 1 is greater than 0. Well, what are you complaining about? And cannot be applied to operands of type int and bool. Okay, let's just do puzzle dot length. Okay. Okay. Bool inversions even. No, inversions odd equals inversion count and 1 is greater than 0. Inversion count and 1. Inversions odd. Inversions odd. Inversions odd. Throw new invalid new exception. Did not find a 0. Okay, great. All right, we have now flattened it. say arr.length arr.length count pairs such that I appears. Do you count the 0? Maybe that's my problem. I'm not counting the 0. Oh, yeah. Okay, so that's what this is saying. So if ARR of I equals 0, 0, continue. If this of J equals this, then continue. Okay. Now we just put in our numbers. And we see what it tells us. And hopefully it tells us something awesome. Like that everything's not insanely broken. 14, 1, 9, 6, 4, 8, 12, 5, 7, 2, 3, 0, 7, 2, 3, 0, 10, 11, 13, 15. All that. Index was outside the array bounds. If minus. Wow, not solvable. Wow, what a crazy. What a crazy. I've just been spending all this time trying to solve this problem. I'm not sure if you're even still around, SGK7, but I really appreciate your help on that. In fact, let me go ahead and give you a little follow there, because you just saved me a bunch of time. I mean, had to set all this up, but wow, holy crap. Okay, let's talk about what are we going to do then. Wow, I just can't thank you enough, man. Okay, so I have a test set up that can actually determine whether or not this can be found or not. So now let's go and find a different one. Whew. Crazy. All that time. Goodness me. So that's printed wrong? I don't even know what to do about that. All right, let's just choose another small one. So that's just a total misprint altogether. No idea how to fix that. Not one idea. Let's try a different one that's got a small number. Here's one right here that goes to 46. Let's try this one. 7, 11. I have this open still. Let's get one of these small ones. Number small. That's a big number. That's a small number. This one, 7, 11. This is the one we want. Holy wow. Man, that made my day. Okay, let's try this other one then. Goodness me. I should just make it so that I can paste the commas in there too, because that would save me some time. True. Let's just try it. Wow, that one failed too. I have to have this backwards. Hey, what's up, man? I appreciate the follow from earlier. I saw that, by the way, right before I got started. Lurking's totally fine. Oh yeah, replacing the commas. Yeah, because I have a bunch of these already, like in this other place, and yeah, let's just do that. It'll just take a second. Initial state. Initial state dot replace comma with nothing. Okay, great. Done. Okay. Let's go check the magic checker and see if it thinks that this one is solvable or not. And I am going to lose my mind if it turns out not to be the case. 7, 11, 8, 3, 14, 0. Oh, you're back. Hey, so I found a little thing on putting that one change in took less than remove. Yeah, I know. That's hilarious. Yeah, so no, it turns out that using some like online check, well, first I wrote it. First I wrote one right here to check whether a thing is solvable or not, which is, come on, is solvable. All right, so I wrote the logic to determine whether or not it's solvable, and then it showed that that one was not solvable, which is crazy to me because I swear I have solved that problem before. So then I was like, I don't trust my own code. Let's go online. Let's find somebody else's code. Let's try their code out. So I went to this place. Hey, guess what? Here's a thing to check whether or not it's solvable. So then we go and we're like, okay, let's implement that over here, because when I tried to run this, it just didn't run. It like gave me some sort of error output. Yeah, fatal, whatever. I think I calculated it as 40. That's an easy thing to test. Is solvable inversion count dot dump play. Oh no, 35. Yeah, you're right. Oh, what? Oh, I didn't finish. Goodness. Sorry. 1 second. Let's get back to the actual original puzzle here. I was like halfway in the middle of typing all of that. Alright. So that's the original puzzle. And then if we say down here, inversion count dot dump, now we're going to see that it's, yeah, I got 40 for it. Oh yeah, you got 40. Okay, great. And the start row is 2, and if it's even, then the number of inversions should be odd. Yeah, exactly. And if the start row is odd, then the number of inversions should be even. Right. Okay, so now what I'm doing is I just ran it for a second one from the Corf paper. I just ran it for another one of these. This one right here, 7, 11, 8, 3, 14, 0, 6, 15. 7, 11, 8, 3, 14, 0, 6, 15. 1, 4, 13, 9. Let me just double check all these. 1, 4, 13, 9, 5, 12, 2, 10. 5, 12, 2, 10. And I ran this through mine, and it told me that this one was not solvable either. But I really want to run it through this example here just to double check. 8, 3, 14, 0, 6, 15, 1, 4, 13, 9, 5, 5, 12, 2, 10, 55, and false. Wow. So that's 2 that I randomly chose from here that it told me were not solvable. And now I'm just like out of my mind. Let's try this one right here. This one's short. Number 42. Number 42. Number 42. This one right here is supposed to be easy. Yeah, okay. Let's give this one a shot. Number 42. Let's try that now. Wow, how are all of these failing? Literally all of them in the Corf paper are not solvable? This is like blowing my mind. Yeah, sure, I have it right here actually. There you go. I tried to look for errata on this as well. Let's try this one. Look, this one seems short. Number 55. Number 55. Not what I wanted. Always click on things that I didn't mean to. Number 55. 55. Okay. Run test. Wow. I just have to think that something is completely backwards here. I only found one source for this. Control F inverses. Explicitly bidirectional search, no. Okay, let's go back to this and let's see if I can do this. How to check if a 15 puzzle is solvable. I found these. If it's okay, so if it's even, which is true, then we say, is the blank row... Oh, see, this is saying even to even, and this one's saying even to even. Where is this person getting this? Well known. They are arranged in random ordering, just large enough to hold 16 tiles on a 4x4 grid. The tiles are then slid around the tray. Not all configurations are solvable. For example, the configuration in which the last 2 tiles are swapped is not solvable. That would be odd, and odd is not solvable. Am I reading this right? So take a look at this one. If this one is not solvable, this is on an odd row because it's on row number 1 from the bottom to the top. And there's exactly 1 inversion. So that's odd and odd. And if that's the case, then all of these are then my solution logic is just backwards. But this one that has the code written in it definitely seems to have opinions. Let me just go back. Did this open in a new tab? Yeah. The last one isn't solvable. Right. You're talking about this one right here. What's the +1? Show me here in my code where I'm making the mistake. So this is counting the number of inversions, and this is counting it correctly. And then down here is the part that really matters. If the number of inversions is even, the number of row... Crap, that is the stupidest feature in all of text editing, is highlight, drag, and drop. Like, why is that here? So if the number of rows is odd, then you just return whether or not the number of inversions is even. If it's, this is not the case for a 4x4. So then what we're saying is it a blank row is even, counting from the bottom. Because there's an even number of rows, and we treat the very first index as 0, odd inversions. I don't quite understand what that means. Odd inversions check even inversions. Let's see. Is the length of the board even? Yes, it's a 4x4. Check for odd number. Oh. Check for. So a 4x4 is check odd inversions plus the blank row. Okay. If I understand what you're saying correctly, this is inversions plus this dot blank row mod, not mod, remainder 2 equals 0. I don't even care about this anymore. Whatever, just leave it like that. So is this what you mean exactly? So for odd number of rows, check that there is an even number of inversions. For an odd number of rows, right? Check that there is an even number, right? Got it. Okay, so for an even number of rows, I am checking that the number of inversions, I don't need any of this, do I? Check even. Right. Blank row. Okay, let's give that a shot. Hey, all right, that passed. Okay, great. And then let's go and try these other ones. Right. Solver test. I'm still, I think, just having a little bit of trouble really grasping exactly what's going on here. So, in the case that there is an even number of rows, period, then I'm taking the number of inversions plus whatever row it's on. So if it's on an odd row, then it will flip whether we care about even or odd. Yes, okay, I got this. So this says if it's on the last row, we're going to add 1. Or in this case, we're going to add 3 technically. And then the number of inversions is, so you want odd and odd to equal even. Yeah. Okay, I got it. Okay, wow, I really appreciate your help there. Let me just double check that all of these other tests were solvable or were not solvable. And then I'm going to come back to this and we're just going to see. Quarf problems are here. Okay, so the number one that we wanted was this one. And then we wanted, what else did we want? We wanted one of these other ones. On a 3x3 board, you need to check if the number of inversions is even. Okay, let's check that. Yes. So if the number of rows is odd, then check that the inversions are even. Inversions remainder 2 equals 0. Right. Looking at this, does this look right to you? I also really appreciate your time and hanging out, man. Or woman, if it may be. Last one should be x mod 2 equals 1. Oh, then all these are going to fail again. These are going to fail. Okay. All right, I'm going to pull like 3 more of these from the Corf paper. And then I'm just going to run them and we're just going to see if they all fail. If they all fail, I'm just going to have such a hard time believing that this logic is correct. Let's get some random one down here that's going to take a long time. No, those aren't the ones I want. These are the ones I want. Let's get this one randomly selected. Let's get some other ones. Wish you would stop doing that. Let's just get this one because it looks different. And let's get this random one right here. Okay. When it is even, when n is even, an n by n board is solvable if and only if the number of inversions plus the row of the blank square is odd. I remember doing this problem when I was learning a priority queue. Oh, that's funny. Okay. If all of these fail, I really am just going to have, yeah, they're all failures. There's just no way that all of the ones in the Korf paper are not solvable. Although we do have some pretty good evidence to believe that, based on trying to solve it. And so, okay, right here is why I believe that it is not solvable. Because when we went here and we said if cost equals 43, you know, int something equals 1, and then we're just going to put a breakpoint here like that. And then what we're going to do is get back to this solver test. This is the one that we had. If we debug this, I remember that, yeah, way back when. I remember that there was one that was not solvable, and then the guy proved that it was not solvable. So the trick here is I was like, okay, let's get to the point where we're at 43. We know that the answer according to Korf is 45, so we should be really close to the correct answer. And then when I went and looked at the state, I don't want the initial state, I want the current state. And what we see is that copy value, that this is what we end up with. Actually, it's just this. This is where we're at right here. And this is, it's on the bottom row, and there's exactly one inversion. The rest of all of these are in the correct place. So we should have been very close. But if this one is not solvable, and this one is, then at some point I have made some mistake. However, I can't seem to get it to the point where I truly believe that this one is not solvable. And that makes me think that I got somewhere wrong from here. Like I'm doing some sort of swapping wrong. And so what I wanted to do was write this function to test. Yeah, let's just go ahead and stop this. I wanted to write something on here to test whether or not a state was solvable. And then literally every time I pop one off the queue, check if it's solvable. And as soon as we find one that is not solvable, go look at the parent and see where it came from. And that should tell us where the problem is. Like with my swapping logic. Only problem is, this is solvable thing is just returning false for all of them all the time. So I'm a little confused. No by default. In the beginning, you check for solvability. I agree with that. I'm having a hard time believing that all of the states listed in this paper are not solvable. That's where I'm having... That's where I'm having the trouble. And I think that I'm having trouble believing that all of the states in that paper are not solvable. I'm just having a lot of trouble with that because I just have code that solves them all. So for odd number of pieces, each move changes the number of inversions by an even amount. That's something that we can just take a look at and test. So for an odd number of pieces, let's take a look at this. If I move the 11 down, I gain 3 inversions. If I move the 15 over, so let's just do that. 15. I gain 0 inversions. If I move this down, I gain 1 inversion because I improved one. I removed an inversion. And I added 2 inversions, so that's a net of 1 inversion. What's your first lesson to learn AI? Well, that depends what problem you want to solve. I think that's generally the best place to start, is just choose a problem and then think of different ways to attack that problem. Ensures you don't need to check for solvability for every move. I mean, the only reason I want to check on every move is because I believe that my swapping logic has a problem. I'm just going to pull this up. I got to do this now. Let's go to these Corf puzzles. In puzzle. I'm new to this. Well, so again, it comes down to the problem. What you're talking about right now with genetic algorithm, that's a technique for solving a problem. Think of a problem that you want to solve. Like, for instance, the problem that I am working towards here is I want to solve a large-scale search problem so that I can apply large-scale search to finding the best way to do dense matrix multiplication on a processor. That's the problem that I want to solve. Mapping it to a search problem and using some sort of like A star or something, you know, along those lines is the direction that I'm taking. But those are just techniques for the problem that I want. So for an even board, the number of inversions plus the blank plus the row of blank squares is invariant. For an even board, the parity. Right, okay, I'm starting to understand this. So you're going to gain an odd number of inversions, or reduce. You're going to shift by an odd number of inversions, but your row is going to change. So what happens is every time that's why you add in the row number. Okay, this all makes sense? So let's just start with, actually, this is a great way to do it. We know that the goal state, okay, I'm starting to believe you now. Here's what's happening in my head, is we have our goal state, which is 1, 2, 3. It's basically this, so let's just put it here. 11, 12. 13, 14, 0. This needs to be a 15. This needs to be a 0. Okay, this is our goal state, and this has a 1 plus 0 inversions. So the total number of inversions plus the row needs to be odd. So if we move the 12 and the 0, 0, and 12, we now have 3 inversions plus row number 2 is 5, and that leaves us with an odd number again. So I believe this to be true. No matter what, all right, this is your equals 1, makes sense to me now right here, right? We're saying that the blank row plus the number of inversions. So if I do as, maybe it's the way that I'm calculating blank row. 0 is the top 1, 2. So if it's here, I need an odd number of inversions. Yeah, no. Okay, this still makes sense. Okay, I mean, I believe you. This makes sense. It's really, really strange to me that I have managed to... I need to print out int bool. I'm going to return the number of inversions just so that I can see if I'm calculating them correctly. Because I just told you that I was calculating them incorrectly, or that I was calculating them incorrect. That I was calculating them correctly, but I didn't actually know there. Improving the property of the system. Okay, so let's take a look at this. Search in puzzle test. Is solvable. Dot item 2. And really what I want to do here is say initial state, no, output. Please tell me I have this. I do have this. What the crap? What is it? Test base. Output. It is called output. Silly helper not helping me. Where was I typing? Right here. Output dot. There we go. Right line. Of initial state. And then I want, why is this giving me hell? An object reference is required for the non-static field. Oh. No wonder I made these all static tests, duh. Surprised they even run. Okay, great. Therefore, because each move maintains the invariance of each swapping, you don't need to check for solvability for each operation. Right, I totally agree with all of that. I gotta understand how I need to get a 4x4 starting state that is valid and then actually run a real test. That's sort of what I'm getting at here. And for some reason, it's blowing my mind that none of the states in this paper that claim to have solutions have solutions. That's what's going through my head. I mean, I totally believe it. Stupider things have happened. Yeah, I already did. I did, right? So this was the whole point here is I started off with the goal state. And I said, all right, with this as the goal state right here, I have 0 inversions, and it's on the bottom row, and the bottom row counts as row number 1. So the row number plus the number of inversions is odd. That makes sense to me. Test the most trivial permutation of that solution. Can you tell me a little bit more about exactly what you mean there? The most trivial permutation. I suppose, like, we could just put the 12 in this, would be 1 away. I'm going to come back to this. I want to finish writing it out. And then I want to say, this is me checking to make sure I'm counting the number of inversions correctly. I'll put the right line. Inversions plus inversions. Come on, seriously? Oh, wait. Okay. Bar sol equals sol dot item 1. Okay, let's test this one more time. And hopefully what we see here is some numbers that we believe. Okay. I am counting 41 and the correct number should be 40. Is that right? No. Where's the one that I care about? This one. I am counting 40 inversions. I'm counting 40 inversions, and it's on the second row. That's 42. That's not solvable. Wow, that's really mind-boggling. I mean, I totally believe it, but that is so mind-boggling. I'm just like out of my mind about it. All right, let's sort of just mix one of these puzzles up and then go from there. In linear algebra, you have heard of the term integers are closed under addition. No, I'm not familiar with that. I don't know what it means to be closed as in like a mathematical sense as an operation. Is that an easy concept to understand? Any permutation can be reached by swapping, and so for every permutation in the set of solutions, if it is in that set. Okay. So then let's just do this. 0. Let's put the 8 here. Let's put the 0 here. Let's put the 7 here. Let's put the 8 here. Actually, why don't we just randomly generate one of these and then calculate it? Operation B is still in the set. Okay. I'm gonna have to go back and read through all the stuff that you said. Each operation is closed. Oh, I get it. So as long as we're only doing swapping to reach that state, then we are still in the closed set. Got it. I think that'll probably take a little more time to sink in fully and for me to really understand what that all means. But it makes sense. It makes sense for this particular problem. Okay. So does anybody have an example board? I'm just like, I'm really out of my mind that every single one of them from the Corf paper is turning out not to be solvable. Just like really out of my mind. Just completely out of my mind. Let's go with taking them and fixing exactly one inversion. Set of operators, swapping, set of operands, set of all solvable configurations. So if you have an element in set of all solvable configurations with a closure property, anything is reachable. Okay. So if I start out in some solvable configuration and I perform any operation that does not result in a configuration outside of the solvable set of configurations, then it's called a closed operation. Am I understanding that right? Then the set is closed under that operation. Ah, perfect. Okay, great. Okay, all right, that definitely makes some sense. Okay, let's take any one of these states that is all janky, and let's fix exactly one inversion. How can I fix exactly one inversion? I can swap the last two elements and safely fix exactly one inversion as long as the last two are inverted. Such as these two right here. So in this case, if I swap, well, first off, let's just make sure that it thinks this one is not good. Come on, man. You can do it. Okay, great. So inversions is 80. And swapping these two should result in... Swapping these two should result in 79. Yep. Whoa. And then this should be true. And it should pass. Wow, look at that. So this is a solvable configuration, then let's give it a shot, right? How many moves do you think it'll take to fix this? Seems like quite a lot because there's some big numbers up top. Let me choose one of these. And I can't. Let me choose a low cost one and then swap actual. Here's a 42. Nope. Here is one that only takes 1,000,000, and I can fix the inversions at the very end. Let's try this first. Solvable, not solvable. Should not be solvable. Failed. (11, 3) run test. It is really astonishing to me that all of these are failing. And now by swapping these last two, I managed to get it to pass. And now I want to see if this can actually be solved. Okay. So let's say you want to reach from A to Z, where A and Z are both in the set of solvable configurations. Let's say F equals swap, then Z is reachable by performing a crap load of swaps on A to eventually get to Z. Where F of A is solvable configuration is in solvable configuration because F of A is in... where each F of A is in solvable configuration, and because F of A is in solvable configuration, F of A is also... This is part of inductive thinking. So when we say integers are closed under addition, let's say A and B. Oh, this is saying that if you add two integers, you won't end up with a non-integer. Right. Okay. Yeah, no, that all does make sense. That makes total sense. What does not make sense is how this paper has a bunch of solutions listed for unsolvable states. That is still blowing my mind. In the most frustrating way. Yes, I certainly can. The optimal solution lengths for 100 randomly generated 15 puzzle instances using iterative deepening A star with Manhattan distance heuristic. And then these are... Oh, look at that. It used a different goal state. No wonder. It used a different goal state. Wow. Wow, that's frustrating. There's the problem. Wow. No wonder. Wow. No wonder the Manhattan distance was off, was not represented the same. No wonder the solution length was not represented the same. And it's obvious why all of them are solvable in this state, because the zero is on an even one to start, not an odd. Wow. That is so frustrating. I chose a different goal state. I chose a different goal state. That's the whole reason. Woo! Why did I choose a different goal state? I chose a different goal state because the everyone else uses the different goal state. Because everyone else uses a different goal state. I did, yeah. No, I really appreciate that. That's something like that's what this is all about for me, man. Is just learning. Like that's the whole reason I want to do this in front of other people. I would not have learned that this year, this or today, this month, this year, at all. Like that's just something that never really like occurred to me to do, but it definitely seems valuable to have in like my back pocket. Oh, look at that. The goal state. They all put the blank in the top left. That's so frustrating. That's so frustrating. Okay. Well, I think that is going to be about it for today, and I'm going to call it on this and basically say, do I go and change my goal state to match what's in the literature? I think so. I think I'm going to do that. I think that's what I'm going to do. No. Why not? Disjoint. Disjoint. By changing the goal state, it changes the parity. It's all putting them in the top left-hand corner. Man, it's so frustrating. So frustrating. Okay. Okay. Yeah, I am gonna call this for today. This was great though. Let's see, what did I get done? Figured out what's today? 2019, 2019, 06, 01, 02, 06. Got some really nice chatting going on and learned a ton. Specifically, closures over sets with operations. I'm not exactly sure how to say that. Look more into this. Look more into this. And in fact, I think I'm going to go ahead and just give you a little at SGK7. Okay. And then I also learned I'm using the wrong goal state compared to what's in the literature. Okay. What did we actually accomplish today? What a great question. And the reason that it works for odd is because in odd, it doesn't matter whether you have it in the top left-hand corner or the bottom right-hand corner, it's always on the same evenness of row. Okay. Gotcha. There is a linear time algorithm to compute the parity of number of inversions. And a possible extension is to represent all states using... Right. I'm not 100% concerned about like compacting the state size just yet. It's not going to be that important for like performance reasons until we move to iterative deepening anyway, um, which we're going to have to do at some point. But I right. Okay, let me just finish getting all of this written down. So what else did we do? I've just lost track. I've been focusing on this so much. We ran a test. The test was broken. We noticed that it was broken because we looked at the output and saw that it was getting to a value far faster, or it was getting to a value higher than what we expected to be the goal. Okay. I fixed this one inversion. Let me go ahead and see if we can actually solve this state. I don't want the Manhattan distance. I want the solver test. Run test. Let's look at the output. Should be the last one. 43. And there we go. We found the goal. Look at that. 52 moves. Okay, great. So we can do this. We can do this. Okay. Okay. That's really it. That's all that happened today. Wow. It's funny. That's how software development goes sometimes. But I think the understanding of all of this definitely got a lot better. Okay. Don't need this anymore. I think I am going to change. I think I am going to change the goal state. So let's just add this to the to-dos. And the reason really is that I want to be able to compare all of this stuff to the literature as we keep going on and on. Change the goal state to match the literature. Okay. Change the output to just show the stats for the last time period. That was actually done last week. What else? Improve the nodes explored. So this is related to what you were saying about using represent all states using log n bits for an n by n board. So you have 16 factorial possible states. So you are telling me take the log of 16 factorial. Yeah. Okay, that totally makes sense. Yes. And the way that is one possibility. By doing that, you really make it difficult to do the swapping operation quickly, which for exploring things, I don't know how to do that. How to do what? Oh, yeah, no. This is actually like when you're talking about pattern databases, which is what one of the next papers is about. It's not a particularly difficult thing to do. There's just a little bit of like, in fact, I have code for it right here. What you need to do is get the index in a pattern database. There's going to be a function for getting an index. That's learning it. Get pattern domains. Generate C values. Bit count. Initialize PDB. this is it, the hash, the pattern key. This function right here is exactly how you do that. The only thing is that number can get quite large. Like, I mean, 16 factorial is a pretty ridiculous number. Yeah, that's a pretty ridiculous number. So clearly, like, having an array this large is not like a realistic thing to do. And you, for a very, very, very small log, yeah, what's the log 2 of this actually? How do I get to the log 2? Can I get to the log 2? Copy. Gonna have to go to like Wolfram. Wolfram alpha. Let's do log 2 of 16 factorial. I don't need an explanation, buddy. I just need a number. Did I do this wrong? Does it even give me a number? 44. Oh, there it is. Decimal representation. Yeah. So yes, you can store all of this in 44 bits, but by increasing it to 64 bits, you take no loss in speed, and your operations for doing swapping are enormously faster. But yeah, the code for it is right here, and this is actually available, like, if you want to go take a look at this, it's on my GitHub. GitHub. And then heuristic search. And then source. And then in puzzle. And then pattern database. And then line 244. If you want to take a look at how to do that. This is doing it for... This is doing it for a pattern database. If your pattern database contained all 16 elements, then this would be correct. However, this also supports doing it for a subset of the tiles. So if you wanted to only index, like, say, 6 of the tiles, but there's 16 locations and any of those tiles can be in any of those 16 locations, this will still create the correct index into a perfectly sized thing that is, what, 16 minus 6... Well, 16 factorial, 16 minus 6 factorial. So yeah, it would use 10 factorial. I can't remember the exact way to calculate it. It's all in here. If you just look around in here. That's it. Anyway, I got to get going. I am way over. I actually normally only stream for about 2 hours, and it's getting close to 3 o'clock, so I got to get running. I really, really, really appreciate everybody stopping by, and I really, really appreciate everybody who is actually chatting today too. Like, this was such a great experience for me. I learned so much, and I had a blast doing it. I stream 3 days a week, Wednesday, Thursday, Friday at noon. This is pretty much what I'm going to be working on for a while, with the exception of next Wednesday, which I will probably be doing a review session for a test that I have coming up for one of my classes. For the closure stuff, look up inductively defined set. Okay. Inductively defined sets. Is there a YouTube on this? Give me a YouTube. Inductive definition of sets. That's what I'm talking about right there. Alright, I will definitely check this out. And again, thank you everybody for stopping by. I'm going to go ahead and get going. Please come and hang out. Like I said, I do this 3 days a week. I do it on Wednesdays, Thursdays, and Fridays from noon to 2. Sometimes I go a little long. And that's it. Like I said, we'll just be working on this. And again, my big goal is to try and figure out how to make matrix multiplication a little bit faster. And right now, we're taking the approach of applying search to doing that. But that's it. Thanks a lot. And everybody have a good one. I'll talk to you later.